Hello my dear students and welcome to my Easy Maths class. Today's topic circle and circle related problems belong to mensuration. Already you have come to know lots of problems about circle and triangles, quadrilaterals, etc. Today I have found few very interesting problems. All of you must concentrate on these problems. Just see, you have to have clear ideas about these problems and you will be confident enough. Okay, let's see what is given here. A square of largest area is drawn inside a semicircle. Largest possible square have been drawn within a semicircle whose radius is r. Okay, we have to find the area of the square. Again we have to find ratio between the diagonal of square and radius of circle. Okay, let's start. Here semicircle have been drawn, okay, and within semicircle largest possible square we have to draw. Let's say this one being largest possible square, A, B, C and D, and radius of square is say R, radius of semicircle is R, okay. ABCD is being considered as the largest possible square. Now, what data we can gather from here? Joining OC. OC is nothing but radius of semicircle, isn't it? So, OC will be R, right? I am considering let OD is equal to A. So, OD is A. Now, we can find one thing. Here OD is A. This one is also, OB is also R. OBOC is equal to R, isn't it? OD is A, that is being considered, and OBOC is equal to R because they are nothing but radius of semicircle. Okay. Using Pythagoras theorem, we can find from triangle CDO, from triangle CDO we can write CD square is equal to OC square minus OD square, that is R square minus A square, okay. Therefore, CD is equal to root over R square minus A square, right. So, CD is A square minus root over R square minus A square. ABCD being a square, we can write, since AB is equal to BC is equal to CD is equal to AD, that is equal to, we can write 2A, considering OD as A and OA will also be A, ultimately AD will be 2A, that is equal to, we can write root over R square minus A square, right. All are nothing but each side of square, because all of you know very well that ABCD being a square, all the sides are equal. Here CD have been found as root over R square minus A square. Since AB is equal to BC is equal to CD is equal to AD, that is equal to 2A. Therefore 2a is equal to root s r square minus a square, isn't it? Therefore you can write, by squaring both we can write 4a square is equal to r square minus a square. Therefore you can write 5a square is equal to r square. So a square is equal to r square by 5. R square by 5 square unit. Okay. So a square is equal to r square by 5 square unit. Right. Since the only data given here is radius of semicircle, which is r. So already we have found. Therefore you can write area of square is equal to r square by 5 square unit. Okay. Now what to find? Ratio of diagonals of square and radius of circle or semicircle, whatever you can say. Now diagonal of square means, say BD is the diagonal. Okay. Diagonal of square is equal to, say BD square. Say BD square is equal to, or you can say diagonal of square is equal to side root 2. Okay. Side root 2. Side here is 2a. 2a means side root 2. All of you know diagonal of square is equal to side root 2. Okay. Side means here it is, say twice a root 2. A means how much? A is nothing but r by root 5 into root 2, that is 2 root 2 by root 5 r. So we have found diagonal of square. Diagonal of square means all of you know side root 2. Side being twice a or 2a. Already we have come to know about the relation between a and r, which is a square is equal to r square by 5. So a is equal to r by root 5. Right. This a is being replaced by r by root 5. Now we got this one as 2 root 2 by root 5 r. So the ratio between diagonal of square and radius of circle. Diagonal of square is to radius of circle, that is equal to 2 root 2 root 5 into r is to r, that is 2 root 2 root 5 is to 1, that is 2 root 2 is to root 5. This will be answer. Okay, very interesting problem, very much conceptual. Try to understand. Maximum possible square have been drawn within a semicircle. So first we have to find the relation between each side of square and radius of circle, which is given. Here it is given as r. Okay. So my dear students, what I would like to say you, please go through it very carefully and do it by your own. Okay. Once you will be able to do it by yourself, you will be very confident. I am coming back with another problem. Okay, here is another very interesting and important problem. Just see what is given. In equilateral triangle ABC, G is the incenter and circumcenter. Okay. Next. In equilateral triangle ABC, G is the incenter and circumcenter. Right. The circumcircle of triangle ABC is inscribed by a square. So, by a square PQRS, find the radius of the circle which circumscribes the square. So, there are altogether 3 circles. Okay, what is given? Step by step, follow it. In equilateral triangle ABC, there is one incircle, another circumcircle, and G is the incenter as well as circumcenter. Okay. Next, the circumcircle of triangle ABC is being inscribed by a square PQRS, means the square PQRS circumscribes the circle. Here it is PQRS. Okay. Now we have to find the radius of circle which circumscribes the square. Another circle that circumscribes the square PQRS, that we have to find out. So, triangle ABC, equilateral triangle, G is the incenter and circumcenter for incircle and circumcircle, and then the circumcircle is inscribed by a square, means the square circumscribing that circumcircle. PQRS is the square, and there is another circle which circumscribes the square. So we have to find the radius. Now we are considering, let each side of triangle ABC be A or A centimeter. Okay. All of you know that in radius is 1/3 of height of equilateral triangle and circumradius is 2/3 of height of equilateral triangle. In radius is equal to 1/3 of height of triangle ABC. So 1/3 into √3a by 2, and circumradius is 2/3 of height of triangle ABC, that is 2/3 √3a by 2. A by 2 √3 we can say, and here we can say A by √3. Okay. So in radius is A by 2 √3, circumradius is A by √3. Okay. Now what to find out? Square PQRS circumscribes the circumcircle. That is, circumcircle inscribed by square means the square circumscribing that circumcircle. Okay. Then we have to find the radius of circle which circumscribe the square again. So all of you know very well that in case of circumcircle, here it is given or here it is shown in black. So radius of circumcircle, diameter of circumcircle is equal to diagonal of square. We can write, since diameter of circumcircle, here it is outermost, is equal to diagonal of square PQRS. Okay. So diameter of circumcircle which is outermost is equal to diagonal of PQRS. Right. Now so that is equal to, we can write, so diameter of circumcircle outermost is equal to diagonal of square. Diagonal of square is side root 2 of PQRS. Okay. Each side of PQRS is diameter of circumcircle, diameter of this circumcircle. Okay. What is diameter of circumcircle? Circumradius is a by root 3. Then side is equal to diameter of circumcircle into root 2 of PQRS, that is equal to twice a root 3 into root 2 of PQRS. Okay. It means how much is coming? 2 root 2 a by root 3 unit. Okay, and this will be the answer. We are writing one thing here. Since each side of square PQRS is equal to diameter of circumcircle. Here it is inner circumcircle, because there are two circumcircle, one is outer and inner. Okay. So the answer here is 2 root 2a by root 3 unit. So try to understand. Here each side of triangle is being considered as a triangle being equilateral, and all of you know that in radius is 1/3 of height of triangle, which is a by 2 root 3, and circumradius is 2/3 of height of triangle, that is a by 2/3 of height of triangle ABC, that is a by root 3. Now diameter of circumcircle outermost means diagonal of square PQRS. So the question arises, how to find diagonal of PQRS? First, all of you know that each side of square is equal to diameter of circumcircle. Okay, here it is being used. Diagonal of PQRS is side root 2. Side root 2 means, side means this one. That is, here it will be twice a by root 3. Okay. So after putting diameter of circumcircle, here is twice a root 3 into root 2. That is ultimately 2 root 2 a by root 3 unit is the required answer. So my dear students, this one is a complex problem. Step by step you have to explore. Okay, please take your time and then try to understand this one. Before exam or after going through lots of problems, you should face these sort of problems. Okay. During our next class also, I will show you another this type of questions. Till then, goodbye.